Hello, and today we're going to learn how to solve linear inequalities. Both types, simple inequalities, which is just left side and right side with an inequality sign, and compound, where you have something in between two other boundaries. Let's first take a look at some properties of inequalities. So rules for solving inequalities. The addition property of inequality states that if A is less than B, then A plus C is less than B plus C. This property holds true whether you have a less than, greater than, less than or equal to, or greater than or equal to sign. It's basically kind of a spin-off of the addition property of equality. If you have an inequality, the inequality remains the same whether you add a constant to both sides or not. Alright, the multiplication property of inequality is slightly different. If you have an inequality, let's say A is less than B, and you multiply both sides by C, the inequality sign does not change if C is positive, but it reverses if C is negative. We could do a quick example to show you. So we have 5 is less than 10. But if we multiply both sides by 2, so which 2 being a positive number, this would be 10 is less than 20, which is true. If we multiplied both sides of the equation by negative 1, though, so we're multiplying by negative c, we get negative 5 is less than negative 10, which is 100% not true. We would have to rewrite it with the sign reversed. So instead of a less than sign, we have a greater than sign, which makes this true. So basically, the rules for equality apply to inequality, with the exception that if you multiply all terms in an inequality by a negative number, it reverses the sign of the inequality. Alright, so let's take a look at solving some simple inequalities. Alright, in this case, it looks like we're trying to isolate the y so we can get an inequality in terms of y. Let's use the addition property of inequality, so we're going to add a negative 8 to both sides of this one. And remember that adding anything, whether it's positive or negative, doesn't do anything to the sign. This becomes 2y is greater than or equal to 10. And then we're going to need to get rid of this 2, so we multiply by the multiplicative inverse, which would be 1/2. And we do that to the side as well. So this becomes y is greater than or equal to 5. So every value that's greater than or equal to 5 would satisfy this inequality. Now let's do this one over here. So again, we need to isolate the 8s. Let's first start by using the addition property of inequality to get rid of the 7. So we're going to add a positive 7. And we have to balance that off by adding a positive 7 to this side too. So here we just get negative 3h, and over here we get 24. Alright, now we need to get rid of this negative 3, so using the multiplication property of inequality, we're going to multiply by negative 1/3, and we have to multiply this side by negative 1/3 as well. We multiplied by a negative number, so what that means is the sign is going to reverse. Instead of a less than sign, it's going to be a greater than sign. So negative 1/3 times negative 3 is 1, so we just have it up with h. The sign will flip because we multiplied by a negative number, and 24 times negative 1/3 would be negative 8. Okay, so in this case, h has to be all values that are greater than negative 8, and then it would satisfy this inequality. Alright, let's take a look at solving compound inequalities. Compound inequalities kind of use the same thing, it's just that you're actually doing the addition property and the multiplication property to both sides, both boundaries of the inequality. And you'll see what I mean in a second. So our goal is to isolate the c, which has a negative 1 coefficient, and it's got an 8 added to it. So what we're going to do is we're going to do the addition property of inequality. We're going to add a negative 8 to everything. So we have 2 plus negative 8 is less than negative c plus 8 plus negative 8 is less than 11 plus negative 8. So notice that in this case, because it's a compound inequality, we don't just add the negative 8 to the middle to cancel out that positive 8. We also have to add it to both boundaries. So this becomes negative 6 is less than negative c is less than 3. Okay, and then we have to multiply everything by negative 1, so that, because negative 1 is the multiplicative inverse of negative 1, so we have to multiply everything by negative 1. So when we do that, we reverse the signs because we're multiplying by a negative number. So negative 6 times negative 1 is 6. This sign reverses. Negative c times negative 1 is c. This sign reverses. And 3 times negative 1 is negative 3. Now usually you're used to seeing it go from smallest to greatest, so we're just going to, so 6 is greater than c is greater than negative 3, or we can rewrite that as negative 3 is less than c is less than 6. Okay? Let's take a look at this one over here. We need to get rid of this negative 3 by adding 3 to everything. So negative 1 plus 3 is less than 2j minus 3 plus 3 is less than or equal to 9 plus 3. So using the addition property of inequality, we added 3 to everything. This becomes 2 is less than 2j is less than or equal to 12. Okay. We now need to get rid of this 2, so we're going to multiply it by 1/2 because that's a multiplicative inverse, and then we're going to have to multiply everything else by 1/2 as well. Let's just do it this way just to clean things up a little bit. So we're going to multiply everything by 1/2. Okay. It's a positive number, so this the inequalities do not switch. It's not now a greater than, it's still less than. So 1/2 times 2 is 1. 1/2 times 2j is just 1j. And 1/2 times 12 is 6. So there is our solution. J is in between 1 and 6, non-inclusive of 1 and inclusive of 6. Okay. Now let's take a look at the example problems I gave at the beginning of this video and just go through them. If you want to, pause it really quickly, do it on your own, and then see if yours matches what mine are. Okay, I'm going to go through this now. We're going to use the addition property of inequality. We're going to add a negative 1 to both sides. So we get negative 2x plus 1 plus negative 1 is less than 9 plus negative 1. This becomes negative 2x is less than 8. We need to get rid of this negative 2, so its multiplicative inverse is negative 1/2. So we're going to multiply both sides by negative 1/2. We're multiplying by a negative number, so my inequality sign is going to switch. It's no longer less than, it's a greater than now. Negative 1/2 times negative 2 is 1. We set that up on purpose. And 8 times negative 1/2 is negative 4. So my solution is that x has to be greater than negative 4 in order for this to work. Okay, let's go down to the compound inequality. Let's first get rid of this negative 5 by adding positive 5 to everything. So negative 3 plus 5 is less than or equal to 2x minus 5 plus 5 is less than or equal to 11 plus 5. Okay, let's clean that up a little bit. This becomes 2, this becomes 2x, and this becomes 16. Alrighty, we now need to multiply everything by 1/2 using the multiplication property of inequality, and because that's a positive number, let's see, nothing is going to change with my inequality signs. They're going to remain less than or equal to, both of them. So 1/2 times 2 is 1, 1/2 times 2x is 1x, and 1/2 times 16 is 8. So there is our solution. Okay, and that is how you solve both simple and compound inequalities.